talk about the scan alignment tool properly, we have to go over the steps we need to take in order to get to a point where we're ready to use it. So, and I spelled that wrong right off the bat. Wow. Let me hurry up and switch the slide here. Okay. Not a good start. Okay. So we need to talk about the proper ways to make use of the scan alignment tool from start to finish. Okay, whether that's your first choice, your last choice, or something you've never heard of, there's a proper workflow to get from the start to the finish. And we're going to talk a little bit about why I focus a lot on workflows. So having a workflow allows you to be consistent, and getting consistent results is the objective of all surveyors when they use a tool. And the VMX or the VMQ or any of our RIEGL systems is no exception to that. We want it to be a tool, not a fancy sideshow. So we're going to talk about the QA/QC process, adjustment tools, and then specifically about SCAL. So I have a sample data set I've been using. It's from the training symposium, so many of you might notice it and recognize it. It's a small sample from one of our users that did a job in South Carolina. It has control, has markers on the ground, so it's a really good sample. And it obviously, if you look at this picture briefly and you're familiar with 2D height differential plots, excuse me, you'll notice that the pink is where everything is above, and there's lots of spaces where it's not very clear, especially due to the multi-pass situation for the intersection just south of the main highway. So workflow. All right, so we have two separate workflows that meld together. One deals with the trajectory processing, and one deals with the RIE process section of the data. So to quickly talk about trajectory processing, there are some key things we have to go over just as a reminder. We're not going to go into PAWSPAC today or belabor these points, but they're kind of important, and while they seem like small subtleties, they're really critical in making sure that your end result is correct. So I created a PAWSPAC checklist a few years ago, and I found it to be very successful in helping users get ready for their project. So I included that as part of the handouts with this webinar. So I made it a Word doc file. If you don't have Word and you need a PDF version, just send me an email after this and I'll make sure to fix that for you. But I want it to be editable so you can add your own notes to it to make changes as you see fit. So just going through this quickly, the important things to point out is that you got to check what your lever arms are and the mounting angles. So if you have a VMX or a VMQ, you know that the angles are fixed. They're not going to change from mission to mission. But if you have a VMQ particularly, you need to make sure that the swivel rotation that you use for that project is the one that's in there. And that same goes with the lever arms. So they should be very tightly mounted and very fixed. And if you're not fixing them in place during PAWSPAC, you're allowing them to float and adjust and getting different answers each time you run through the algorithm. The DMI is the same way. You need to have a precise measurement as possible, but you also have to allow the lever arms to float a little bit as your vehicle is on suspension typically. Obviously, high rail vehicles are a little bit different in their suspension as you're more or less fixed to a fixed solid wheel as opposed to the tires that are going to change as they heat up. Base station coordinate datum. So that is really important to manage as well. There are a couple routes to take. You can fix the datum to match your control. You can make it ITRF00, but you need to know which process you're going through, and you need to be consistent with that and you need to document it. So again, I'm not going to get into that today. You need to make sure you set your base station correctly. So if you know that you went out there and used a 2-meter fixed rod tripod, but the answer says, but in PAWSPAC, your review of your base station says that it's only 1.8, you need to make sure that it's corrected for that. So having consistent surveying equipment for when you set up base stations on your own is very critical. And if you don't know the quality of the information that you're getting, do your best to verify it. The sooner you have you know where your errors lie, the better off you will be at correcting them in post-processing or not having to deal with them at all. And check the quality. Go over the trajectory quality. Does it make sense? Are you dropping out more often than you should have? You know, if you were in a complete open sky situation, but you're seeing a lot of peaks and valleys in your quality graphs, there's probably an issue somewhere, and you got to take a quick review of that. All right, just moving right along here. So having a workflow is an organized approach, right? In my process, we have a lot of iterative functions. However, our iterative functions, they can make improvements, but they can also use up a lot of your time, especially getting into a RIE precision feedback loop where you keep running it over and over again without making any changes and expect a different result. This is going to lead to a lot of frustration and a lot of time watching status bars move and waiting for data to process. So one of the things I would like to stress as you look at this workflow and work with your data is, what are the clear changes you made between the first time you ran it and the second time, or the third or the fifth? Making sure you understand that is very critical in moving forward with a positive change, right? And that's why I propose these questions should be asked when you're considering a reprocessing of the data. Why will it change? Did I do anything to get a different outcome? What do I expect the results to be? If you are just running it again because it's the next thing on your workflow checklist, you should know why you should expect it to change. Because if you're not changing anything, the algorithm doesn't inherently know that you want it to do something different. And then you should ask yourself, is there a reason I shouldn't do this? I think that one's really critical, because sometimes we get into the mindset that just doing something for the sake of doing it will improve our results. And at the end of the day, this isn't man-in-the-loop or person-in-the-loop computing process. It's not an automated algorithm that just takes your data from the scanner, processes it, and produces a perfect point cloud. This is a in-the-loop process. It wants your involvement and your expertise to weigh into how it's functioning and how it's working. So that's a bit on workflows. We're going to move right into the QA/QC. So what do we have available? Well, we have control reports, automated selection, where you can go ahead and have it automatically find the center of known targets. I mentioned last webinar, we have chevrons, we have rectangles, we have flat circular discs, and we have checkerboard patterns available to you for the computer algorithm to go check and find where there's issues. Is it always going to get it right? Good heavens, no. Should it get it right most of the time? Most likely, but there are reasons why it could make a mistake. Then you have the ability to still manually select the correct point for the algorithm, or for the control point, rather. Visual inspection. This is the most valuable tool you have in order to quickly assess the data quality, and that's using this 2D heat map that we'll go over in a little bit how to create it. You create a plot from the 2D view. And then 3D structure inspection. There's really no substitute for you going into the data, taking cross sections, and looking at it in 3D to determine if it meets your standard or not. There's no fast way for a computer to display 3D results in a 2D manner. Analysis tools. So within the program, we do have some really great ability to check out individual points and locations along the path of both the trajectory and inside the point cloud. If you haven't held down the I button on the keyboard and used the left click mouse button to see all the info, you're missing out. There's a lot of great information there. And then at the same time, you can also use T for trajectory, and you can click with the left mouse click with the left mouse button. Oh, that's a tongue twister for you. And you can pull up the trajectory view and see exactly where the issues are. Well, not the issues per se, but where the quality is. So are you at a point where you have a lot of obstructions? Are you at a point where everything's clear, but you're getting different results? It's a very valuable way to analyze the data before raising the alarm. So 2D visual inspection. This is where I start every project. I get back from doing a job, I process the data. Okay, so this is after I've made copies, I've done all the things that I need to do here. And here we have a visual inspection. Okay, so this is a 2D plot. So what you do is you go into your 2D view, you load all your records, and this is scaled height difference. So the scaled height difference is showing you the absolute value, the difference between the lowest point and the highest point in the point cloud. So if you have 10, 15, 30 passes in here, you're going to have some variations between each pass. That's to be expected. And especially if you look at the situation of this typical interchange, you can see the white represents where the trees are. The dark blue represents where the data is actually better than 2 centimeters. And then the color slowly goes up until white is above about 10 centimeters of error. Well, difference, because trees obviously wouldn't be considered error. So you can see that we have spots. Let me get out my pencil here so you can see. So you can see we have spots down here. Oh, of course it's black. Hold on. I mean red. So you can see we have spots down here in this corner that are going to need attention. And that makes sense because we have on and off ramps there. You can see here we have an interchange that's pretty messy. We have this bridge structure here, so we don't actually know the status by looking at it because the bridge is higher, is 10 plus feet off the below record data from the underpass. So that's going to be a challenging area. And then we have this area in here that needs looked at. I'm getting crazy, but this side seems pretty clean. So that's it's pretty typical setup there. And you can see, in the shoulder here, see there's the road surface on this part. If I draw that, that looks clean, the actual path. But you can see right off it is the soft target area where you're going to have some differences in the grasses due to the different angles the laser data saw it because you probably got some shots from the highway as well as from the off-ramp and probably some from over here. So there's a melding of data there that saw different angles into the soft targets. All right, so now that I've made that all messy, I will erase my drawings. So this is a required, in my opinion, a required save for all users. So if you're going to say that you ran raw precision and you didn't get the results that you wanted, what's the first question you have to logically ask after that? It's, well, what did it look like before? And this is a quick way to compare the before to the after. And if you don't have that, it's really hard to make a claim that didn't do what you wanted it to do. So save this picture. It's valuable. And when it's not in a PowerPoint slide, it's easier to zoom in and out of. Yeah, there we go. So 3D inspection. So here I took a bunch of 3D cross sections. I zoomed in. I looked at my bridge structure, my curving, how everything fit together. It looks as I would expect from a multi-pass job where the side features here are a little messy and there's some indentations along this sidewall here. That's why you see the shots on the end cap there. That's actually this. There's breaks in the barrier. So you can see it looks pretty good from far away, but as you zoom in, you see more differences and offsets. So then we get into running control reports. So control reports are always a hot topic with everyone, and everyone has different things they want to do and different things they need to look at. Uh-oh. Sorry, that popped up. Okay, so to do this, right, we have to first run the auto tie planes or the automatic feature extraction to get a whole database of all our control points. So we run this through and we then need a way to look at it quickly to determine and analyze our results. And so that's the scan data adjustment tool. So it's not the alignment tool, it's the scan data adjustment tool. And that makes a nice listing of all the deviation values within the project. And when I ran this, I ran all my controls I normally did. I didn't do anything special, just ran it through the usual steps in the find time points wizard. And it came up with a couple of things that I noticed right away. And you can see down in this bottom right corner here, there is a very large offset from one of the points. So I'm able to go into this and go and inspect that. And there's a few other ones that are quite high as well that sort of stand out to me. So you need to go and inspect them. You figure out, okay, what went wrong? Or is it right? And now as this is a point that it finds, these are a 3D vector point. So all the values are going to be positive, whether it's positive or negative in terms of its location with respect to the control, the data set. All right, so if it's above or below, it's all going to be positive because it's a vector. Okay. Okay, my little required stamp. So I came out to control point 202. As you can see here, one of these things is not like the other, and that's the tag that's in the middle of the shoulder brim. And that's clearly in the wrong place. The data does not look like it's that off. So this is a shot from the other side of the highway that didn't quite see this, but because the reflectance value, it wanted to at least tag it and give us let us know that there's something there, but it couldn't really see it. So this point just needs to be removed. So that's a simple check and remove scenario here. Then we go to the next one that I found on the list, and this is the control point 15, and you can see there's a cluster of points around the yellow main point. So yellow 215 is the main control point, and you can see there's some that are closer. There's one pass that's closer than the others. And okay, well, what's going on with that? So we check the green tag, and you can see right away that from this pass, which was on the main highway, this happens to be a control point on the shoulder, that didn't really see enough of the data to make a determination of where it should be. Anyway, maybe I could squint at that and look at that at the right angle and really guess correctly where that center is. But my eyes aren't comfortable doing that typically. So that's another one I would remove because there's too much error in it. Then we came to another one that I found on my list that had some wild variations or some subtle variations between each control value at 205. And you can see here from the 3D cross section that there are a couple different layers here. So you go, oh, geez, what happened? Is it wrong? Did I process the data wrong? What's happening? Where's the error, right? And you can go here to the 3D view and you take a look and you go, oh, okay, I got power lines overhead. I got trees that are pretty high on both sides. If I zoom back out to 2D, I can see this is right where the intersection happens, so there's the intersection, then there's the actual on and off ramp. So there's a lot happening in that area and a lot of passes there. So yeah, it kind of makes sense that it's off, but let's verify that. Does the trajectory, what story does the trajectory tell us? So I come in here with my T-click tool. I'm able to click on that point and it pops up the trajectory view. So this has my POF file from my SBET, and I'm able to see very quickly here that one pass shows that I'm on the downswing, and this shows that record 12 was kind of happy during that pass, so it had a good quality alignment or a better one. It was on the downswing of that curve. If I go to another point, I'm seeing that that point there is sort of on the upswing of the error curve. So the error was ramping up at that point. So there's obviously some things that's going to be considered in my precision while it's processing this. So this is all good information. It doesn't tell me exactly what's going on, but I get a sense that, okay, there are different accuracies here from different passes, and the trees definitely played into the obstruction of the area. And you can see this is for record 10. And there's a couple other records in there, but you get the point. You can analyze this for yourself and make sure, does this make sense? And I determined that it made sense that there was offsets that varied because there are clearly various levels of quality through this pass. So then after I cleaned these up, I went ahead and did a final report analysis where I analyzed it one more time. So I'm always using the analyze button. in this in the scan data adjustment tool, right? I'm always clicking this analyze button. It sometimes pops up and tells me, hey, buddy, there's not enough points on 1 or 2 records where you didn't see anything because they weren't located near control points. That's totally fine. You just click OK. If you've ever watched me do a quick presentation, I clicked through that so fast you wonder if I even read that. The answer is no, I didn't. I just assumed that's what it said. So anyways, there's nothing to do here except for save this report. And if you give me a quick second here, I can quickly jump out and show you that. Just let me pause it. All right. All right. So if you've come up with some questions, go ahead and ping me in the question box. I see a few are coming in. That's good. It means everyone's actively engaged. Excellent. I'll get back to those at the end of the session. All right. And I'm back live on my screen, I believe. Let me check the audience view real quick. And that is the case. Okay. So here is the SCAL output from that. So this is not SCAL, excuse me. That's the name of the webinar. This is the scan data adjustment protocol output. And you can see it gives you a quick overview of all the input parameters, blah, blah, blah. But the important part that we're looking at is we're looking at what's the initial standard deviation, how many observations do we have, and you get that we're about 0.03 or 3 centimeters to start with all the control that it found. And we're not moving anything. You see all these are zeros. We're not shifting anything. This just gives you the report of the VMX's lever arms and mounting angles from the bore site calibration. And this does the same thing for the INS GPS. Again, we're not shifting anything in this case. We're just using it as a before and after comparison tool. So as you would expect, we have some objects that are spot on the money, which is good. They're all 0. That's fantastic. That's what we expect. We expect that some of our control through this process will align precisely with our first round of data processing. That makes sense. And then we're going to have some that do not match. And you can see here, we looked at 205. That was definitely one that had some error in it. We could have also looked at 206 that has a little bit more error in it, and so on here. So there's some variations between it. Nothing is overly stands out. Again, this is a 3D vector deviation, so it's the aggregate of the x, y, and z as a combined number. So it's not strictly x, not strictly y, or strictly z. All right, so this is a saved out protocol report. Okay, and you can add descriptions into it. You can add more comments. I just write before adjustment. Okay. Now, if I jump back into this full screen here. All right, so you got to save this. You can also highlight all these records and save them out as a Excel file or CSV of all the control offsets, so you can do your own analysis and make your own statistics. I'm happy with this, but there are other ways you can do it. So then the next question you have to ask yourself is, what are my critical areas? And if they're critical, how do I add, what's a way I can make sure that they stick together? Or not stick together so far as, how do I help guide Rye Precision in its adjustment? So one of the things that I've been advising folks on for quite a while now is to add in control points, or control planes rather, known as tie planes in this case, along 3D infrastructure pieces that they want the data improved upon. And so that overpass bridge is an area that we're going to be focusing on in our SCAL use, as well as our Rye Precision use. So we want the best possible outcome. And I've found through trial and error and through many years of experience that adding my own tie planes to 3D structures like that really helps improve the overall alignment. But For every project, only you know what areas are the most important for the deliverable and what the overall job spec was. So this is something for you to consider. There are other things to think about in terms of car noise. Was there a particularly high volume of traffic on the road? Was there a lot of semi-trucks that could be mistaken for common surfaces? Or is everything, standard where there's just a few cars here and there? But if you had a semi-truck sort of follow your path both ways, you probably need to really focus on removing some of the car noise to make sure ride precision doesn't make any false positive analysis. It shouldn't, but why chance it? The other thing is, how many passes did you use, and did you need them all? Do you want to limit some now before you run ride precision, or are you wanting to roll the dice and and just hope everything works out well? And then control, like, are you going to limit which control points are used, or are you using all of it? All these things play into a factor, need to be thought about before you go through and run ride precision for the first time or 15th time. Hopefully our goal here today is to help you make ride process more ride process and less reprocess focused, if you don't mind the pun. So tie planes, all right. So I think it's a good idea to go ahead and add them to critical areas. So I did that for this. We need to really check when you make a tie plane surface, like under the bridge here, that all your vectors are pointing in the same direction for the same point normal. So they create a normal to the direction in which they were created, and you can see that these go to the left and these out here go to the right, which I'll give you a moment to think about why that is. All right, if you came up with because one of them saw it on the way through the bridge, the other saw it on the way out of the bridge, and it's an I-beam, so it's wider than that, you're right. So this is a bad plane to pick. So you got to be very careful that you're not trying to shove two surfaces together that don't belong. So if you're going to do this, take your time, make sure that things match correctly. So by calling them tie planes, they really must match. They can't just sort of match. They really need to be the correct surface that you're matching them to. So be careful not to make the area selection too wide. So I did a few sections like this on the bridge as an example for this webinar. See, I selected the curbs, the top of the sidewalks, and I did some on the bottom here. I don't think they're really necessary on the bottom of the bridge, but I like to have a clean cross section on those I-beams when I check it post-process. So you notice I'm not selecting wide surfaces along the road surface. There's a couple reasons for that. One is that there are sometimes potholes in the road, and if you select the big surface there, it's really tricky you're asking it now to match everything together spot on, when in fact it doesn't match perfectly. There's a slight angle there, so it all depends on how you're looking at it. So just be careful when you're doing this that you don't either overdo it with too many tie planes. And again, if you're wondering how do you make a tie plane, you're using the space bar in the view, and you're doing the left click mouse button to create an area, and then there's a tie plane button or a tie objects button along the top toolbar that kind of looks like a shadow box with a star on it, like an asterisk star in yellow. I'll point that out when we get into ride process here in a moment. And then you select tie planes and it creates tie planes. So you want to be careful about your making of tie planes. You don't need to do too many, and you don't want to overly define the same direction. So you go, okay, wait, same direction, what do you mean? So I'm talking about if you're to define the vertical needs to come together, that's like the best area for ride precision as it is. It's pretty good at picking that out. You want to not over define, you want to pick one on the vertical and then one off to the right and left alignment. And if you have anything in the along direction, sort of like a flat sign, a corner of a building, that's also a very key thing to use. Now, on a bridge infrastructure, unless you get the exact end cap, and you're not always going to see it from multiple passes due to the angle that you're looking back and forward at it, it's very hard to have that. So you're really just focused on helping align the curbing together correctly. And since it's an overpass, it has pretty good GPS resolution. You're not unlikely to see in a long track. So a forward or backwards is what I mean by a long shift in it. But you should be on the lookout that you're not finding that while you're doing this selection. All right, so let's review where we were. All right, so we talked about a QA/QC process. So one of the main things that we want to do before we even start running RIE Precision here, we have not done that yet. We're just looking at our data and evaluating it. We want to make a 2D height plot graph, the differentials, the absolute values. We want to know what it's going to look like before we run it. Where are the areas that are a question? The next thing we want to do is we want to bring our control in, analyze the control, check out what those results are, go clean it up if there's a problem with it. Third, we want to take some screenshots of what the 3D structures look like. We want to make sure that we have a good understanding of what they look like before we ran RIE Precision and what they look like after. We want to double check our control quality, right? Where are we at? Are we sure this is the best control file from our surveyors, from the project survey team? Or is there going to be a revision that's coming out 2 or 3 days later that we're waiting on, but we're like, hey, let's go ahead and process it anyways. Let's be constructive of our time. Everyone's time is valuable, and so is compute time at the end of the day. If it's not going to be ready until Monday, don't start processing it on Friday and expect not to have to redo it. Let's go check your POSPAC checklist. Even before you process the data, did you check off everything? Are you sure of the lever arms? Are you sure of the DMI? Are you sure of the base station coordinates? Are you sure of the base station height? If you're not sure of any of those things, go ask. And you're going to need to ask the person to set up the base station. All right, just double check. So we already talked about this, control point evaluation, ingest and correct it. Like, is it the final product? All right, adding the tie planes to critical areas of interest. If your job is to do all the curbs in a community, they better be really tight. You're going to want to add extra control planes and tie planes on those points to help improve the alignment. Don't trust that a computer algorithm is going to do what you want. Help it out. Make it do what you want. All right. So now we are ready for adjustment and alignment improvement. All right. So we run RIE Precision. It's our ace in the hole, best tool to use. All right. It's a comprehensive adjustment. It's not focused on one area. It doesn't take a lot of input on your part. You follow the steps and you adjust it, right? And what does it adjust on? It's adjusting it based on your control and the automatically found features. By adding additional tie planes, you're also adding those, okay? And it has a comprehensive algorithm approach. So it's not doing it just at the key sites that you're interested in. It's doing it along the whole time period of the trajectory, from start to finish, anywhere where there's overlapping data, okay? And it's doing adjustments based on the timing positioning of it and not based on an overall alignment, right? So it's like you're adjusting the clotheslines to match that you hang the data on. So if you picture, that's sort of the best visual example I can come up with in my head that most people agree on. If you think back to the olden days of hanging clothes on a clothesline, the trajectory is the clothesline and the data are the clothes. And the data is hung out to dry on the clothesline. So we're going in RIE Precision and we're making slight adjustments to adjust and improve that alignment of the clothes back on the clotheslines, not on the data. Okay, so if you think about it as from an airborne perspective, what typically is done in an alignment routine is you're adjusting the clothes to match each other. That's the strip to strip alignment methodology that does not really work in the mobile field. And for those that have been with the VMX since its beginning 10 years ago now, know that that was a really challenging time period when we were doing things like stopping underneath bridges, or stopping after we went through bridges, not underneath, that would be bad, but stopping after bridges to help reacquire GPS to try to avoid jump discontinuities. So there have been many improvements since we first started this journey with the VMX 10 years ago. And we've had many tool improvements along the way to get really the best value out of it. So some of the new folks that have come on to mobile scanning in the last couple of years, they're spoiled, quite frankly, because RIE Precision does a lot of things for you. So SCAL, or Scan Data Alignment Tool, was the original RIE Precision module or improvement. So it was the next step in the progression from strip alignment to RIE Precision. And this step allowed you to set up many sites, and I'll show you what I mean about those in just a second here. You get to preview what it will look like and how it affects other sites before and after it. And it really allows for complete and total control. And you can type in exactly the adjustment you want to make on it. So with that knowledge comes great responsibility on you, the user, which is why we don't spend a lot of time focusing on this, because it can open a whole different set of problems. So that's why I'm being very careful before we go into that. So if you're disappointed that you haven't seen SCAL yet, that's why. Yeah. So how good was RIE Precision this time? Well, pretty good, to quote Larry David. As you can see here, we have dark blue everywhere. I adjusted my scale that anything under 2 centimeters of deviation was blue. So we have really great blue data along the main trajectory lines on the highway, as I would expect. There's some fuzz in there from car noise, maybe some shots from the overpass, a lot of things that we can crop out from a range standpoint before we do the final export. As you can see here, it's pretty cleaned up. We can see there's some start and stop issues in one of the records where it has a big X down here on the southern side. Let's see if I can do any better drawing this time with my pen. Check the color this time. Ooh, I'll just put an arrow out. Yeah, okay, and I'll do orange this time. All right, so you can see here, there's some issues there. We don't know about the bridge, as you can see, because we have the underpass data as well as the overpass data. So that's going to be mismatched. Maybe there's some issues in here to look at as well. And my arrow is popping up at different areas and moving. That's not your screen delay, that's true. And looks like some car noise there. We'll have to check that out. But overall, it's a really clean plot. I'm very happy with the performance of RIE Precision. All right, so there's that. So just to remind you, there was the before, and there's the before, there's the after, sorry, and there's the before. So definitely a big improvement in terms of percentages and alignment. All right. Ooh, I'm going the wrong way, sorry. All right, so what are we going to cover in the Scan Data Alignment Tool portion of this webinar? All right, so this is where you can get out your pen and paper if you've been waiting for the important information. Here it comes. We're going to talk about the settings, what they are, how they work. We're going to talk about the different modes of operation in terms of what it does. I'm going to go through the methodology of how to apply it. Then we're going to go through a quick sample. And let me note right up the front here, if you use the SCAL tool and then want to run RIE Precision, you have to export the trajectory before you can do that and re-import it. So it's really not set up to run SCAL and then RIE Precision. That's why I ran RIE Precision first, and now I'm using SCAL to touch up areas that I want to improve. Now, you can go, yeah. All right, so let me pause my screen while I get everything set up for the SCAL portion of this. Just a moment, folks. Yep. All right, just a second here, just making sure this all opens up. Oh. Okay, well, you got to see me do that. Okay, so I didn't really do that. My apologies. Let me check the audience view, make sure we're all caught up here. We are, all right. Welcome, this is RIE process, in case it's something you haven't seen before, and this is the scan alignment tool, SCAL, okay? And you can see here I did a quick setup where I've already created some sites, okay? So in order to start the SCAL tool, you must have an active view. Active view, SCAL icon becomes available in the top right of the toolbar. Now you could have your toolbar arranged in different ways. I happen to have mine spread out in a single bar. That's all user preference. You can also, just real quick, this is the desktop control, and you can actually have different setups available, and you can save them right there. Just a quick extra tidbit of information for you. So I have fewer than all of the data loaded on purpose here, because I found out during my testing that my laptop starts to complain about having all the data loaded at once. That's why it's a laptop and not a processing power horse. So know your system. So if I zoom in here, you can see I have these sites posted up here. And I'll just show you real quick how you make one. So let me just slide back a little bit here. I'll make some right around this little divot here. I'm going to go in here, and you have some options. You have create single site or create multiple sites. I recommend that if you're new to it, you always create a single site so you can size it correctly. So, and the way you want to approach a fix of the data in an area is you want to put one where the data looks good, one where you would like to adjust the data. So I need to create another one here. Right, and then you want to create one afterwards where the data is good again. I keep forgetting that I don't have it on multiple sites. So we're just gonna put one right there. All right, so this is the middle one is for adjustment, and the two ends are to stop the alignment from propagating throughout the rest of the point cloud. So as long as I haven't done any results or calculated anything, I can click on these, and I double click them, and they become active, and I can stretch and move them. So I can make it fatter, I can make it thinner, you can make it wider, and I can move them. Right, so I want to make that a little bit closer. And it really truly doesn't matter which direction the arrows point, because it's going across the whole data set in the area that you're interested in. It's going to adjust all of the data within that bounding box. All right, and if I click on that one and make that my active one, typically you get a split screen here that tiles the view. So you get what the area in that bar looks like here, and then you get the 2D view. I'd love to show it that way for you, but I don't want my computer to have any hiccups and crash during this, so I'm going to just toggle back and forth between 2D and 3D, and it gives me some more ability to move and manipulate the data. So we can see here, this is the setup. You can see that it agrees with itself because it's only one pass here, so there's really no reason that the 2D view is bad in this area. Because single data set, and you can see there's a nice trailer with some supplies on that for the construction that apparently is impending for the interchange. Always cool to see what's off to the side of data sets. So that tells me that this data set, this little blurb here, is really from, as we passed this multiple times, there are some shots down the hill. So I'm going to be skeptical that there's going to be too much to change here, because it's going to be pretty thin on information. And if I look at this carefully here, I don't see it. There's not an obvious visual offset, right? And again, it looks like only one line. So we're going to go ahead and let it analyze the data, as I call it, to show us what's there. So that gets down into this part of the sites. So this box here tells us what is the active site that we're in, right there, site 10. So it's highlighted there, it tells you it's 10 there. All right, this gives you some sizing information about where it's located, and then we have different methods. Really, there's only one, it's called the plane-based methodology, and we're gonna do what I call a default search, and if you wanna see what those settings are, you hit the wrench there, and it lists the defaults that we have for this. And they're read-only. You can create your own. If you want to create your own, you use this and you hit copy, and then you can call it new one, and then you can edit them and adjust the values. The main things you would probably look at adjusting would be the minimum point count, because that's going to allow you to minimize how big the how much data has to be found. So if you have a VMQ, you're probably going to want to lower that because each individual pass would need fewer points. So you can change these settings and minimize what you're searching for. But you probably don't want to do that until you know what it finds in the first place. So one of the tools we have is expert mode here, where it actually shows you what it finds. So we're going to go ahead and enter expert mode here and let it do a quick analysis on it. And it's going to stop when it gets to the plane point and let us look at the planes before we approve it and go on to the next site. So it's going right now, it's loading through the data, it's analyzing it, and it's going to pull up and tell us what I thought it was true, was that using this parameter set, we're not finding any additional data within the view. And you can see it filters down the data. So it pulls out the trees. It's just looking at the hard surfaces here, and it also pulled out the power line too, as it was pretty continuous and thick right there. So it's thinned out the data. It didn't really find any observations because it's only one. It's one record. It's not two records, and you can see all these are linked. So with SCAL, you're linking the two VMX scanners together. All right, so that tells me right here that as industrious and adventurous as we want to be, this site, this bottom part, this cloud of points that appears in 2D is more imaginary than it is realistic in terms of data misalignments. So there's not enough data there to adjust. So we go, okay, great. That saves me a lot of work. So I just highlight these 3 points and I just delete them. Yep. And we don't need to fix anything there because it's not finding anything. So that part's easy. So now we come to our bridge example. Okay. I added control planes to this, and from 2D view, it looks fantastic. But is it? We're going to start with this middle one here. Yeah. And let's take a look. So it says that it has really good quality, as you can see right here. There's no adjustments. I've analyzed all these. So excuse me, I need to back up one quick tick here. So the first thing I did after I created all these sites was I hit the analyze button and analyzed them all. All right, because in order for you to know how changes affect the previous or the post site, you have to analyze the data because that's how it takes in the calculations. And then the ones in the middle here, so I set this one here, which is site 7, and this one here, which is site 1, as my fixed points where I want the data to stop making any adjustments beyond those 2 barriers. And you say, wait, why do I want to fix the adjustment? Well, if I open up this tool right here, sorry, it's this tool, the timeline tool, yeah, you can see how all the adjustments fit here. Okay, so if you look at site 8, okay, and I zoom out and make this tiny, you can see the expand, oh, okay, I need to make it this way. So these are how close those events are to each other in time. So this is a time graph. Your x-axis is time, and your y-axis is the shift in X, Y, and Z, or north, east, and down in this case. And in this view, you can see how the linear interpolation is happening between each window or each strip. So you can see that between 1 and 8, there's a bit of a, it's coming down, but it's not immediate. right? Because they're a little bit far away from that because there are other sites before that, or this version, or this pass, I should say, excuse me. So between these passes. So there are some things that are happening to the trajectory between the sites. So this is why the SCAL tool is interesting, because you get to see what it is, but dangerous because you're adjusting the data. And you can even come in here as an advanced user and you can actually physically move these arrows and adjust them to get the answer you want. Again, not showing you that because I don't want you to do it. So that's a quick overview of the tool here. So if I go to, which one did I just? So if I'm going to start at 2. Okay, so 1 was just for analyzation. 2 is where I'm starting. So I'm going to the 3D view here. Okay. I see we're approaching the hour mark. If you have somewhere to be right at noon, I apologize. That's going to run a little bit over. We're probably looking at being finished no later than 12:15 with the run through here. Just for those of you that are on a schedule today, or a tight schedule. So if you look at this, you can see this looks really good. And you say, wait a second, Josh, is that what's going on? So this looks great, but let's see, is this a before or an after plot? It's an after. So let's see the original. So the original is what it looks like after Rye Precision was run and before we did any adjustment with the SCAL. So you can see a couple of things here. This has a little bit of a dirty gutter right here. There's some dirt piled up or leaves that have built up there, so it's hard to get that good cross-section view that we want. So I'm going to crop a little bit of the data out here so I can more closely see the changes that were made. So that's the selection tool. So again, that space bar on the keyboard, I can highlight any shape I want. It selects the points, and then I use the star tool to cut it out. So you have to look very closely here to see a misalignment. And since we want almost as perfect data as we can get, we would like those to be slightly more blended. I do apologize, I can't get this edge to catch just right. So there is a difference there. If I make the points fat, you can see them maybe not as integrated well together as I'd like. So if I go to the preview, you can see they're all touching. It's very congruous. Continuous is the word we're going to use. The continuity is good. It's touching. It's congruent. There we go. And we're very happy with that result. That's what we want. We don't want our feature extraction folks to be like, well, the two things are separate. Which one do I select? We want no confusion. We want it all together. So this is why this has a slight adjustment. Okay, and it fixed a little bit in the height as well to make that line up. And you can see that's all very well integrated between multiple passes. It's a masterpiece of multicolor wonder. All right, so that's perfect. So we're happy with that, and I did that by calculating it, and I changed it to the find search so it could find the modules, so it could find the planes. Let me load all the data again. So let me show you the quick example here. If I select expert mode and calculate for just this site. So when you have just one highlighted, it only looks at one site. If you have all of them highlighted, then it steps through and calculates everything. And when you have expert mode selected, it's going to require your approval before it goes to the next one. So if you're using this tool on a big area where you have 10, 15, 20 sites, you're going to want to turn expert mode off. So you can see quickly here that all the planes that it found are in really the vertical direction. So it didn't really find any curving, but the curve offset, as it seems, is it was slight. It was just enough vertically misaligned that it pulled the curving just a bit tighter so that we had that clean alignment there. And obviously now it's already been adjusted, so it's able to pull that in and adjust it. So this is where, if you were trying to have it pull the curving in and it wasn't getting it yourself, this is where you'd want to go in and edit the results in this new one, where we'd want to adjust it and edit these numbers, and we're able to, in one of the expert fields, have it pull the curves, have it pull the the horizontal surfaces. Right now it's not pulling it off, but we don't need it to either. So this is where you would make those adjustments to try to pull that in. So just as an example here, if you drop this down to 10, you can make the search, the angular tolerance is probably one that you need to adjust. That should be fine. Let's try that. Let's do a quick analysis on that, see if that pulls in some curves. By dropping the point number count, you're going to be able to find smaller samples of points. And then you probably need to change the search radius as well to reduce that size. Yeah, there we go. So we are able to get some interesting horizontal features with the curving. And those should be aligned. Very interesting. But you can see down here, some more curves got in there as well. This curb face got in there several times. So that's the kind of the way you want to do it, is sort of adjust those, and then you want to then at a secondary level, you can see we got that railing now too, which is great. That's giving us some good information, adding to that overall quality alignment by changing the number of points. But again, most likely because we added the tie points, or sorry, the tie planes with the control, and there was a lack of control on the bridge, we got a really good result to begin with. So just a vertical adjustment would help it. Yeah, so now it thinks the quality is not as good, but we didn't make any changes to it. We just did a quick analysis, but because it added those in there, it came back with a different result. So if we want to configure this further, we're going to probably drop down the cube size to a quarter, or maybe, yeah, probably less than that because those curves aren't that tall. But this is going to cause it to find a lot more points. Tighten this up perhaps so we don't get anything unexpected. And just one more time, just to show you how you can iterate this and really maximize the value of the system defined automatic planes. Yeah, so we're getting some more on the curving, not a ton, but now there's at least 3 on this curve face that I can pick up right away. And we're seeing a lot more on this side too. Yeah, a lot more surfaces, and we got that top sidewalk. So overall, really good information. Says the quality is not as good. Now that we have these new things, let's go ahead and have it calculate. What do we say? See if it can improve its quality further by minimizing the error source here. Take a quick look at the questions. Ooh. A lot of very detailed questions. All right, so I'll try to answer those maybe offline. So yeah, so just because it has the ability to detect that quality doesn't mean that it has the ability to fix it necessarily. But we are at the 10 centimeter level of error, and I don't really see any 10 centimeter level offsets. Now again, we can go back, and one of the nice features of SCAL is that you can run it iteratively and you can see exactly what is changing. So we can go back to the original, didn't jump a lot, and we can go to the preview, and this is what it would do afterwards. So it really just slightly tightened up the data. It's not making massive changes and adjustments, which is perfect. We don't really want it to. All right, so that's that site. So basically we do this for each site. And now that we made changes on this site, we can go back to site 1 and we hit the analyze button here. It's going to give us a quick analysis of how those changes affected the first site. Because we're making changes, it's going to spread throughout the data set. So how did it change? And since we don't really want it to propagate beyond that, before we need to, once we're all done. So let's say that was the only changes we need to make. And I'm trying to watch my time here and not have this drag on all afternoon. We want to fix these. We don't want it to be changing the data way down the field here. If we look here, I mean, the best indication here, we got this guardrail. If we look at the original and the preview, I'm not seeing any massive change there. The colors are maybe changing slight orders. They're not really changing all that much. So this is where we want to come in here and we want to make sure we hold this to 0. So yeah, it's going to say manually edited, but we do not want these changes, even though they're millimeter level changes, to propagate outside of our area, outside of this bridge. So we set all these to 0. And like I said, the scanner 1 and scanner 2 are connected. So it's not a single scan connection, it's all connected. So that fixes that, and we're good. So now we can go, let me go back to 2D so I can see where we are. So that's 1, so that's downstream a bit. So there's some propagation through here, and that's totally fine. You can add another strip in there if you want to see how it affects it right after that one. We can then look at this one here too. Go back to my find search, as that was working fine for me. Do a quick analyze on it, make sure it's still happy with its adjustments that it's already made. And sort of wrap up here. So sometimes you have dramatic results that SCAL can help pull together for you, and sometimes you really don't. And so it's really a mixed. That's odd. Why is it doing that? Did I leave stuff hidden? No. All right, so it didn't find anything in strip 3, so that's a puzzle. I'm going to have to guess that it didn't load correctly because I wasn't switching back and forth between 2D and 3D correctly. Yeah. So yeah, so as we can see, the changes from that one also improve the quality. The changes of 2 improve the quality of 3, and so that's very good. That's what we expect. Again, likely because I used tie planes. Well, not likely, but because I used tie planes on the bridge initially, I improved the overall quality of this bridge, so there wasn't a major misalignment here. But it is nice to be able to jump back and forth between the preview and the current, so you always know what you're getting. Okay, so that's a little bit on the SCAL tool, how it works, when to use it. My recommendation is to be very cautious about using it. Know what you're doing, how you're doing it, and why you're doing it. These are the sites here that I'm adjusting. So what I will do now, while I close out and answer questions, is I'm going to run the trajectory improvement on the bridge area to improve it. So I have sites here, 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 and here that are calculated, and these, of course, at the end, I need to analyze to make sure that we don't have any spillover into the rest of the data. So let me analyze the last section here as well. And you can tell that I did go back in and add an 8th site into the middle of the bridge after I initially set up, because I wanted one more section, which is why the number order isn't perfectly numerical. So we're almost done here, and while I do that, while this runs through the data processing tasks, I may go through and answer the questions. This webinar will be available afterwards from our webinar download site or viewing site that we're setting up as we add webinars to our online database from all the different segments and topics that we've been covering at RIEGL over the last month or so. This is taking a little bit while to calculate. Let me pause my screen and share a new poll question here. Oh no, oops, wrong button. There's a new poll question that you can answer about RIE precision. While I'm waiting for the results to calculate for this section, because that's a little bit boring. And no, it didn't crash my computer if you're making that adjustment or that assumption. It's perfectly fine. It's just taking its time. It's being very thoughtful today. I can see Trevor is skewing the poll by answering. I don't use it a couple times here, or one of the first people to use it, or to respond. All right, this is going to take a few more minutes here to set up. Let me pop out these questions. Let me see what. Yeah, okay, there we go. All right, so to save a copy of the 2D image, one of the ways that you do it is in the 2D view, if you right click on the screen, there is a create plot tool. And I'll show this to you once we get back into the data set that will create that for you. Yeah, so the scan data adjustment report that I showed you is able to be created whether you manually create the tie points or use the automatic finding tool. So again, it's actually not called automatic finding tool. It's called Find Tie Objects Wizard. It's located under the toolbar in the second subsection of tools. There's a small gray line that defines them. And I'll show you all that in a second. So when I talked about the scan data alignment tool, I was just having it search for the common planes, but not for auto tie planes. All the auto tie planes that I use are only found by RIE precision and not by scan data adjustment. That's sort of a separate topic. But thank you for that question. Seems to be some issues with the handouts. We'll have to figure out how to distribute those. I've never done that before, so if there's an issue, I'll figure it out and include it as part of the distribution. The reason why this current one is taking so long to process through is that there are almost at least 7 records that are in it, so it's taking a little bit of time to do that. Yeah, on signs, typically you do see both the front and the back especially on highway signs. And while they're pretty close to being the same, you wouldn't want to necessarily use those. You don't want to use the front and the back points. And the reason why I usually pick those up with the VMX in particular is because of the forward-backward looking lasers. And so one of them is going to see the front face and the other one's going to see the back face pretty much every time you go down the highway, unless you're obstructed by a vehicle. So if you're using road signs as part of your control points or tie planes, you're going to want to probably not do that. Or at least be judicious about which scanners are which. All right, so that's pretty good on the questions so far. Keep asking them. Thanks for your guys' response to the poll. I'm going to close it here. Most of you guys are still with me. That's great. Close. All right, so actually a lot of you are not big RIE precision users. Interesting. So So we definitely have some room to expand the use of write precision among our users. All right, so now I'm going to switch to my screen again. All right, so to follow up, this scan site finished. There's a few points in here that are non-zero, so no, they're small, but I really don't. Well, so when you click in this, if you use your scroll wheel of your mouse, it actually increases the number. So you got to be careful about that. So I'm resetting those to 0, and that's all good. So those are all manually edited. We're fixed there, and we're ready to have it go rerun the post-processing routine. So that's about the wrap on the write precision side, or sorry, not write precision side. Scan data, scan alignment tool, or SCAL. So I mentioned if you want to save a 2D plot or 2D view, you want to create a plot, you just right click in the 2D view window, right click and create plot, and this dialog box will pop up. You want it to get the project limits from the view here, so you get the right region of interest. And then you need to play around with the resolution and the scale depending on how big your project is, because there is a image size. So if you get over a couple thousand pixels, in the tens of thousand pixels, it's going to fail on you and not generate the photo. You can also change your settings for your laser data right here on what values you want to see, what colors, all that good stuff. You can edit that one more time, and then you can select the output location. You just click OK, and it creates a 2D view for you. All right, so now to close the scan data alignment tool and actually process the data after you've made adjustments, you just hit the exit button and it closes out. And boom, those disappear from your 2D view and you're all set. And I close out of this small box here and the window closes and I get a error message to tell me that it's unhappy about something. It didn't crash the program, which is great. It's just a graphics cleanup bug, most likely. And we jump into the data processing wizard for it to apply these settings. Well, I should show you that first. It applies it as part of your trajectory. So if you go to edit trajectory in the correction tab, there is now a scan data alignment tag. If you decide that after all that, you do not want to use it, you just simply select none and you can process the data again and it will be removed. But since we did all that effort and we spent all that time, we were going to use it. So we click OK, we definitely want to use it. And either way, because we opened SCAL, you can see that all of our RDB files are grayed out, which means if we would wish to export the data, it will tell us simply, I'm sorry, it's not ready yet. You need to process it again. So data processing wizard, uncheck the first box, and away it goes. And I'm not going to create all those extra files. Yeah, sorry. Obviously was processing some airborne job that had some more exciting features in it. So we're just going to do the 2D one. And again, if you've ever set up the RIEGL process or it's the first time you've done it and you've not seen these windows before, make sure you check the Create 2D database, especially if you're going to be using these quality control methods that I've been discussing today. It will save you time looking for where your 2D view is later. All right, so that tasks are all successfully created there, and we're off to the races with RIEGL on my laptop. So we can all take bets on how long that will take. But in the meantime, I needed to show everybody real quick what our RIEGL Precision report was. This is the other saved report that you should always save after you run RIEGL Precision. We've added some great statistics in there now that are beyond just these normal positional plots. So if you've looked at these and said, wow, I really don't know what those are, here's the quick explanation that I can provide you today. Maybe it will help you see it in a new light. So the time is your X scale and the shifts are listed on the side. This is within time. So if your first record matches your middle records, then that's one way to look at it. And it's basically every time you have a record, you have changes. And when you don't have any data, we don't change the trajectory because there's nothing to base it on. So it goes back to 0. And we're doing a 6 degree of freedom adjustment at every point. So we're able to adjust not just the XYZ positioning, but also the roll pitch and yaw, which would be known as your heading vector. And you're likely going to see the heading be adjusted more than the roll and pitch because, as you all know from working with GPS, that's the least accurate component of the INS GNSS system overall. Now, when we look at our absolute adjustment modes, this is dealing with the control values. We get a prior separation value and a estimated post adjustment value. And we usually check these, and I meant to show you that we check these afterwards to make a determination on where the hot spots are. So were there any spots where it really couldn't adjust it? And we can see here at 205, we did have one of those points where we improved it greatly, but it's not nearly as nice as the other spots. So we'll want to take a closer look at that in 3D and figure out what's going on there. But for the most part, that's really the only trouble spot. And we kind of knew 205 was a question spot from the beginning because we had all those lines on top of each other from the interchange. All right, so let me wrap up here, and then we'll finish with some questions. All right. So the whole process of a workflow is to keep our software called RIEGL and not reprocess. Take your time, slow down, think about what you're doing. I presented some really good critical thinking questions that I think all users should consider before rerunning or reprocessing the data, because it's going to save you time on the back end. That's the goal here. It's not to say don't do it, it's to say understand why you're doing it. All right. Use the tools that you have available. That includes the analysis tool for looking at the trajectory and looking at the information provided in terms of, you know, what's where. You know, take your time, look it over, know what you expect to get, and know why you expect to get it. We really made this a methodical process with user access control that allow you to make it a tool and not just a black box of magic. Document your progress, right? If you're someone that runs RIEGL Precision and really feel like it doesn't do anything, but you don't have the before to compare the after, why not? You gotta help yourself out. It's really hard to visualize or remember what a quick look at the raw data looked like without having a before image. Now, obviously, you're not going to export the LAS files and do a differential between every one of them. That's a lot to ask of you. But doing a simple check would be very advisable, in my opinion. Confirm your results. Check the control points. Check the data. Just because it says that it's supposed to be good in the RIEGL Precision report doesn't necessarily guarantee that it is. So check your results. And happy scanning, everybody. Enjoy your journey along the highway, whether it's through life or in the vehicle, through the windscreen as you're driving down collecting data. So that's the end of my formal presentation. I'll take a few minutes here to provide you with one more poll question before we part. Could use some feedback here on what's the next topic for what's the next MLS topic? I've done SCAL now. I did an image processing one. There's always more to cover. Like some feedback on that, where to go. And let's take a look at the questions now. All right, so this is a good question. So we had a question about the minimum size for a tie plane. Well, the absolute minimum size for any plane or surface is 3 points. That's the geometric definition, or a line and a point, or 2 lines that defines a plane. I would recommend probably 10 to 15 points. You want to know that it's a point, or sorry, know that it's a plane. And if you have 50 points and you're not really sure what it is that you're creating a plane to, don't create it. So if you can see what it is, you know what it is, then that's enough points. So all the automatically extracted features within the point cloud are extracted automatically through RIEGL Precision. And they're also done in the SCAL tools independently. So all you have to do is run it, and it does that extraction, and then it also does filtering based on some parameters that you also have the ability to adjust in the SCAL tool. But any actual feature extraction in terms of curves, sidewalks, guardrails, all that stuff, that's not done in RIEGL process. Yeah, so I didn't really cover any of the settings on RIEGL Precision yet, because RIEGL Precision really doesn't have a lot of wide open settings. It's either you use all the data that you have or you don't. So that's one of the main ways, one of the main points to make there. Okay. So with the SCAL tool, everything has to be in the view for it to use it. So if you have 10 records, but you only loaded 2, it's not going to look at the other records, the other 8 records. So they have to be actually loaded in the view to use it for SCAL. I've not found a way to set all the values to 0 in SCAL. If you know it, let me know. The SCAL tool is in fact only for AMLS users. The trajectories and the distance from the trajectory to the ground is too great for ALS data or UAV data for that matter. It's really just a mobile tool. So if you sat through this waiting for some airborne revolutions, it's not going to happen. All right. Getting pretty good response on this. Working through questions, there's a lot of them. So if you have a really particular burning question about this and it's critical, make sure to email me or email my good colleagues at support@riegelusa.com. So that's support@riegelusa.com for any questions in terms of things not working as you expect. And you can always copy myself, Josh France, at my email address, which is jfrance@riegelusa.com. So thank you everyone for attending. I'm not going to be, let's see here. Let me check the progress of my data processing. I think it's only at 28 out of 30. So it's actually almost done here. So we'll hang out for a few more minutes if you want to see the end results. Judging by the before and after, there's not going to be a drastic change in it. And hopefully I didn't blow up my point cloud either. So if you want to see if I blew up my point cloud, stick around. Yeah, so editing the end sites is what constrains the error. Sorry, not the error, but it constrains the adjustment process to just that section that you're interested in. If you don't adjust them, then they peter out over time through typical linear interpolation. But we really want them to just focus on that spot. You have to set them to 0, and you have to hit analyze, right? And in order to make any changes actually occur, you have to have calculated it. So the calculated part is for the middle, for the adjustment part. The analyzed is for the fix or the fixing of the data to a single thing. All right, so I think I got the poll all finished here. Thanks for all the comments. Thanks for all the questions. Thanks for attending. If you've left already, thanks for coming as well. So I'm going to close this. Any more responses? 3, 2, 1. Ooh, we got a really close tie almost between more on data adjustment and a full best practice workflow from start to finish request. All right. Okay. Well, Cameras would be in the full best practice one as well, so maybe I'll bump that one up to the next one, and after that's all done, we'll loop back around and take a look at data adjustment. All right, thank you everyone for participating. We'll take a quick final look at the data here. And again, if I didn't answer your question and you really and you have it, feel free to email me, and I'll also read the questions again afterwards and see if there's something that I can answer. All right, so first of all, good news. I didn't blow up the data because it's still blue on the bridge, so I didn't make it worse, which is usually the goal here. So I used the profile tool and then the wrong button, the wrong alt button. And here we go. Let's take a quick cross section here. How does it look? Looks like a bridge. That's good. The curb alignment looks to be stellar. Oh, sorry. I hope you saw that. That was it. Done. No. Let me realign that here. That's really clean. Happy with it. This extra part is, of course, the side faces, as you can see. So that's the column. So the data came together very nicely. I can load in probably these two records here are the main passes. And obviously it went white because we now have the features underneath the bridge as well. And once again, I'm using the profile tool. That's O on the keyboard, taking a cross section using the Alt key, holding it down while moving the scroll wheel to expand the profile view. And we'll do that right there, a nice big chunk. That's a very clean bridge. I think we're ready to start drawing it. So we lose a little bit of data density there in the middle, obviously. Well, it looks like it was a mistake, but obviously you can see there, that's intentional. So again, this is just a couple passes. It's not all passes, but I wanted to see the alignment of this outside part, and that's a pretty clean tube. There's some points in the middle there because you can see there's a slice all the way through the bridge there. And you can also see that's right where the drainage gutter sort of takes shape there, and some pile of stuff sort of pops through. So we just take a quick look at this. I did also want to show you while I was doing this, the tie plane tool, just in case you're new to RIE Precision or RIE process in general. But that looks like a pretty clean square where we're going to have not quite a full point density on the final touches of it. I think if we line that up just so, you can see that's a pretty good looking rectangle. Almost a square, actually. Yeah, it's a square. It's a square with beveled edges. And we can make some measurements. It looks like perhaps here there's some deviation on the outside. I'm not sure if the point density, the point spacing is in a way, as you can see here, that they don't quite line up with each other. And it's concrete, so it's not perfectly level. So maybe on the outside, these two records, as you're going underneath the bridge, aren't perfectly aligned on the back side of that as comparatively to the much denser points on the inside of the bridge. Yeah, so right there, just full disclosure here. So it's right about the, I don't know, it's like a centimeter offset there. But if you look, it's really sparse on the one laser, and the other laser is much denser. So it's within spec in terms of what I would expect from the laser, but I would like to get that a little bit tighter. So if I was going to run maybe another RIE Precision, I would make sure that I added a few more time planes like that to this. And again, that's making the selection there. You can see all the yellow is what I selected. It's a bit of a longer one, but what you do then is you go up to this black shadow box of a like I said, a yellow asterisk, and you can create tie planes just like that, and that creates them. So I didn't check that before, the outside of the bridge deck. And again, this is just with one pass in it. I'm going to reserve my judgment on whether that needs additional work. It might. That is a tough area to see in general. I would probably refer back to what I was expected to deliver in the final CAD drawings as to whether it was a life-altering thing I needed to fix. But again, all the way along the bridge section, it looks really clean. I'm not seeing any massive deviations as I didn't expect to. And you can check that also in here in the area after the bridge, before we had our final cross section placed. How does that look? And it looks pretty well. It looks pretty good as well. At least it's saying that it does. Let's just make sure it's not lying to us. It appears to not be. The road didn't shift sideways where you get that little offset in the side gutter there. The color differentiations, what you're seeing is there from the slightly different angles from two different passes, getting into the gravel area or the soft area. So again, this is the iClick tool that gives you all the information. So the point that I just clicked on, we know the amplitude, the reflectance value, the deviation value, the target number, whether it's been classified at. I mean, we even know down to how fast the vehicle was moving at this time, which in this case was 30.82 kilometers per hour. So it's very precise. All right, well, for the folks that are hanging out with me still, thank you very much for sticking with me for this extended webinar on the SCAL tool. And thank you very much. Final question here, and it's a perfect one, so thanks for asking it. If you ran Rye Precision again, one of the key things I said to begin with is that you have to export the trajectory. So you actually have to export this trajectory as an ASCII file and bring it back in to be able to use it to run Rye Precision again. So it's coupled, but it's not coupled. And to be honest with you, unless you saw something that you really didn't like after you ran Rye Precision the first time and then you did the SCAL cleanup, it would have to be really bad for me to want to run Rye Precision again. And I don't think this classifies as that, in my opinion. But it's a case-by-case scenario, so I can't say for certain that that's always the case. But good last question, all right? And then in order to have the trajectory pop up for this area, sometimes you have to have it at least loaded in the view, which I did have it. It just didn't come in the crop out. There you can see the dash line represents the T click, so it's T on the keyboard, left click. So if I click over here, you see it jumped over here. Again, this is in the longitude section, so it's super meaningless to most people. But here's this graph here. You can then even check your number of satellites, see how that all looks. Yeah. So everything's there at your fingertips for a quick analysis of the data beyond just looking at it in a 2D or 3D point cloud view. All right, well, I could talk about this all day, and I think a lot of you would be happy to listen to me, but it's getting close to lunchtime for me here on the East Coast of the United States, so I'm going to bid you all a good day and good afternoon and good evening. So thanks again for coming in, and enjoy the rest of your day. Be safe out there, and drop me an email with any thoughts or comments.